So today we're going to be looking at some theorems of complements and supplements, and then we'll also throw in a couple of extra theorems at the end about other types of pairs of angles. So these theorems come from our course text, the green text, section 2.6 and 2.7. It's also found in the supplemental text, section 2.4. Let's first recall what supplementary angles are. The definition of supplementary angles are angles that have a sum, two angles that have a sum of 180 degrees. So we have two theorems about congruent supplements. The first one states that if angles are supplementary to the same angle, then the angles are congruent. Let's look at this illustrated in a diagram. It should be pretty straightforward. We're given that angle 3 is supplementary to angle 4, and that angle 5 is also supplementary to angle 4. So before we show the formal proof, let's just throw some numbers in here. Let's say that angle 4 is equal to 80 degrees. And if we know that 3 is supplementary to 4, by the definition of supplementary angles, the measure of angle 3 must be 100 degrees. And by the same token, angle 5 must also equal 100 degrees. So we can see that 3 and 5 have equal measures, and therefore they're congruent. Okay, so now let's see it in a formal proof. This one I chose to do as a paragraph, just to get you familiar with the different types of proof. So we're given that angle 3 is supplementary to angle 4, so we can conclude that the measure of angle 3 plus the measure of angle 4 is 180 degrees. And then we can solve for the measure of angle 3, and we get the expression 180 minus the measure of angle 4. So similar to how I just plug those numbers in before, you chose any numbers. For any measure of angle 3, we can get, or for any measure of angle 4, I should say, we could get the measure of angle 3 by subtracting it from 180. And then in similar fashion, since angle 5 is supplementary to angle 4, that means that the measure of angle 5 plus the measure of angle 4 is 180 degrees. And if we solve for the measure of angle 5, we can see that same expression, 180 minus the measure of angle 4. So regardless of what the measure of angle 4 is, that expression is the same for both the measure of angle 3 and the measure of angle 5. We calculate those measures in the same way. We take 180 degrees and we subtract the measure of angle 4 from that, and we get the measure of angle 3 and 5. So we can see clearly, no matter what the measure of those angles are, that angle 3 and angle 5 have equal measures, and therefore they are congruent. The second theorem about congruent supplements is very similar. This one states that if angles are supplementary to congruent angles, then the angles themselves are congruent. So let's look at what that looks like in a picture. We're not going to do a formal proof of this one. Okay, so we're given that angle F is supplementary to angle G, and angle H is supplementary to angle J, and that angle G is congruent to angle J. So again, let's take a look. So we know that G and J are congruent, meaning they have equal measures. So let's just say that the measures of G and J are 60 degrees. Well, if F is supplementary to G, then that would make angle F equal to 120 degrees. And if H is supplementary to J, that makes H 120 degrees. So we can see that F and H have equal measures, and therefore they're congruent. So the proof of this would look very similar to the last proof we did. We would use some algebraic expressions to represent the angles and see that F and H would have equivalent expressions, and we can then conclude that they are congruent. Okay, the theorems about congruent complements are basically exactly the same, just substituting the word complement for supplement. Okay, recall again that complementary angles are angles that have a sum of 90 degrees. So the two theorems, again, they're almost identical. If angles are complementary to the same angle, then they're congruent. And if angles are complementary to congruent angles, then the angles are congruent. And again, those proofs look exactly the same as the initial proof I did with the supplementary angles. All right, so two last theorems we're going to look at that they don't deal with directly with complements and supplements, but we actually use when in the proofs of these theorems, we would actually use the theorems about congruent supplements or complements to prove them. So recall that a linear pair is a pair of angles that lie along a straight line. So this theorem states that if two angles form a linear pair, then the angles are supplementary. So if we're given two angles that form a linear pair, ABD and DBC, so again, remember, those are two adjacent angles lying along that straight line, AC, or they form a straight angle, ABC. And we want to prove that ABD and CBD are supplementary. So again, if we just kind of plan it out in our head, what this proof would look like in our head, it is pretty logical that two angles that lie along a straight line are supplementary, because we know that a straight line or a straight angle is an angle that measures 180 degrees. So we want to use all this information in our formal proof. This proof I illustrated as a two-column proof, again, just to get you used to seeing the different forms of proof. We start with our given information as always. And from our given information, we can conclude that ABC is a straight angle. And that's really the definition of a linear pair. Angles that form a linear pair have non-common sides that are opposite rays. And remember that opposite rays form a straight angle. So from that given information, we can conclude we have a straight angle here. If we have a straight angle, we can conclude that the measure of angle ABC is 180 degrees, because that is indeed the definition of a straight angle. We can also, taking a look at the diagram, remembering our angle addition postulate, we can take ABD and CBD, take those two measures, and add them together and get the measure of ABC. Okay, again, that's our angle addition postulate, remembering that two parts of an angle can add up to a whole angle. And then we're going to use a property that we actually haven't seen yet, but it is pretty logical. Look back up here at step 3, statement 3, says that the measure of ABC is 180 degrees. And in step 4, we have the measure of ABC over here on the right side. So if the measure of ABC is 180 degrees, that means we could substitute anywhere we see the measure of ABC, we could substitute 180 degrees, and vice versa if we needed to. So that's just a substitution property. It's really nothing earth-shattering, nothing really you haven't used before. We just haven't formally seen it in geometry yet. And therefore, if the sum of those two angles is 180 degrees, we can conclude that those two angles are supplementary. And our final theorem for today is the vertical angle theorem. Okay, recall that vertical angles are those angles that are like across from each other. So 1 and 2 are vertical angles in this picture. Okay, and by the linear pair theorem, the one we just proved, we know that 1 and smiley face angle are supplementary. And we also know that 2 and smiley face angle are supplementary. So what can we conclude about 1 and 2? Well, we have those other theorems that we learned earlier today that, or earlier in this video, that if we have an angle supplementary, right? So 1 is supplementary to smiley face and 2 is supplementary to smiley face. We can conclude that 1 and 2 are congruent because of the congruent supplements theorem. We'll show the formal proof tomorrow. But for now, this theorem states that if two angles are vertical angles, then they are congruent. And that is it for today. I will see you in class tomorrow.